or problem. Let's solve problem 439. 439. So we have a frame and it is simply supported on this side and its roller on the other side.
Yeah, A is pin, D is a roller.
And the load is 12 kilonewton per meter on AB and height is 4 meter 5 meter. This height is 4 meter and the width is 5 meter. And you want to how much is that?
16.
How much is this?
16.
16?
Yes.
First of all, let's talk about the sign convention. It's very easier for the bending moment, any bending moment. You can just imagine that these are the beams. This frame is made up of 4 beams. This is the beam 1. This is the beam 2. And this one is the beam 3. So you can isolate them, you can separate all these members into different segments. This is the segment AB. This is segment BC and D. And now you can also, because in case of frames, joint B and joint C, they are the rigid joints. So you can also show these joints. For example, you can show this joint is like this, and this is another joint. And remember, any force on the joint you will not show on the member. For example, if you are discussing about the member, you will only show the member forces. You will not show any joint force. For example, if you have a force here, exactly at this point, you will not show here because it's a member. You will show that force on the joint. So, luckily, in your problem, you don't have any joint load. But if you want, I can add.
Only have. No.
Other than this, there is an example, the first example 413. If you see that, example 413, there is a joint load exactly on the member, or on the joint C. So if you want to study by yourself, you can also see that example 413. Do you understand? But at the moment, it's your choice if you want to put a joint load or not. Okay, so the first step, let's find out the reactions. How much will be the reaction here? So there will be 3 reactions, one vertical, other vertical, and third left or right?
Left. Should be left. I think. Should be left. Yeah, it should be left.
Should be left. Yes. Okay, so in order to find the
Moment at D.
VD, VA, let's take moment. In order to find VD, let's take moment at point A. So 12 by 4, 16 by 5 by 2.5.
2.5, yeah.
12 into 4.
Clockwise,
It's
plus 12 into 4 into 2 minus VD into 5. So you will get VD. Do you understand?
Yes.
How much is VD? Tell me. Which position? BD.
59.2.
So BA will be
Summation of
Y.
yeah.
16 into 5 minus 59.2.
20.8.
20.8.
Summation of x.
And BD 59.2. Now this force will be
Equal
sigma fx equal to 24. 12 into,
to
because there is no other horizontal force, so this reaction will be 24. Just, I told you, imagine all these as a beam. For example, if this is AB, just imagine this is beam AB like this.
Picture it's 48.
What? 48, yeah. I'm sorry. My fault.
Just rotate this member AB in your mind and understand it's like beam.
Yeah, like that.
A beam, so this 48 means positive shear.
No, it's negative because it's making it rotate clockwise.
Forget about that. Just, okay, for your help, I rotate it to help you. This is A, B, and it is how much?
In the middle.
20.8.
20.8 and then
This is
48. This one is
48.
48 and this is
20.8.
and then you have a load. I just rotated this one. How much will be? This is 12.
48.
We start from 48.
Now we have to bring this in equilibrium. Or you want to draw the bending moment and shear force, whatever. There are two things. Number one, either you want to bring in equilibrium, it will be one and the same thing, or you have to draw. For example, if you have to draw the shear force diagram, it will be something like this.
Start from 48.
48, it will go up.
Yeah, triangle.
Then rectangular down to 0.
Yeah, triangle going
Linear,
down.
linear down.
0. 48 kilonewton, it is a positive. And then the moment, it will be
concave down.
The parabola,
it will be positive. This is and this coordinate will be 1 over 2 into 48 into 4. Okay, that's all. How much is that? 2 to 4? 96 kilonewton meter. This is how you can draw. It is perfectly like beam. This is what I was telling you. For example, let's draw first the bending moment diagram for this member, for the shear force diagram.
what axis that
Sorry?
the axis from where to where will be? The x-axis.
I did not understand. The x-axis?
Yes, the x-axis. Distance.
Okay, I do it. Hold on.
Because it's vertical and you convert.
هو بس خلاه زي كذا عشان يوم
Please see, I'm going to draw it. That was just for example. I mean, this is the load, this is the reaction, one reaction, and this is 48. For example, now for this member, I want to draw the shear force diagram. And here there will be the bending moment diagram. Shear force and bending moment. So you have positive shear, 48. Okay? And it will go down to 0. Here. And if you see your member, it will be in equilibrium, like 48 minus
It's 48 again.
12 into 4, it will be 0 here. Positive. And now the moment from here will be 0. It will be something like this, parabola. And this value will be how much? 96? 48, this point is 48, so how much is this total area?
48 into half into 4.
228.
96. This is a positive. So this is a bending moment diagram for the, but this member is in equilibrium. What about this member? This member is in equilibrium? Yes or no? No.
Because the moment.
There you have
No,
the
right there.
You have a moment, you have drawn. This is the one part. Now we will bring it in equilibrium, because from this member we have to now move to the other member, this member. Now this member has a load of how much?
16.
Okay, now this is 48. So it is 20.8. So this will be how much? 20.8. Now it is in equilibrium in the vertical direction. In the horizontal direction it is in equilibrium. But what about the moment? Is it in equilibrium for the moment? How much is the moment at this point?
We calculated it. It was.
Just tell me, like 48 into 4.
Into 4. And 12 into 4 into 2.
How much? 12. 48 into 4 minus 12 into
0. 0 to 0 دكتور
96.
اه
It is positive 96. 48 into 4, it's very difficult, am I right? 48 into 4 minus 12 into 4 into 2. The moment at point B is equal to
96.
168.
96.
same.
96, yeah.
So you have a moment here, which direction? The total moment is in the clockwise or counterclockwise?
Counter.
Clockwise. So in order to bring in equilibrium, you have to apply a moment 96 in this direction. See, now this member is in equilibrium. Please see, x, y and moment.
So how you decide that's counterclockwise?
See, this is 48. 48 into this moment is clockwise. 48 into 4. And this moment is opposite of this. So 48 into 4, if your answer is positive, it means this moment is greater. Just try to understand. Do you understand? So it means this member is trying to move in the clockwise direction. So in order to bring in equilibrium, you have to apply a moment in the counterclockwise. Done? Okay. Now from this member, we will move to this joint. Okay, so we have how many forces here? Two forces. One is, now when you will move to this joint, you will just show these two things but with the opposite sign. Okay? Like 20.8, and this moment is counterclockwise. clockwise. Now this joint is not in equilibrium. There is no such force. If there is any force, you will apply equilibrium here. For example, like in your example, if there is a force here, then like 10 or 20, then you will put in equilibrium and you will apply the remaining force here. Okay, I give you an example. Like if you put a force, any force, like 10. So this moment is 96. How you can bring this joint in equilibrium? You need one force, upward or downward here?
Downward.
Downward. How much?
10.8.
10.8. Yes. And you need a moment, and that moment will be opposite to this. It will be counterclockwise. But in this problem, there is no joint force. In this problem, there is no joint force. So this force will be 20.8. Okay? Understand? Finish. It's very simple. Whatever you are getting here, apply opposite here. And what is here, apply opposite here. And what is here, apply opposite from this point to this point. Or whatever you are getting here, apply opposite at this point to bring in equilibrium. Or move from the other side. Do you understand?
Yes.
Okay, let's do next. So now let's talk about this member BC. This is a member BC, and this is a load on this member. This is 16 per meter, 5 meters. And you have one force here, so you will transfer this force from this point to 8 point because it is a section, so it will become opposite. It will be
20.8.
and the moment it is
Clockwise it will be.
counterclockwise,
Now in the forward.
so it will become
Clockwise.
okay. So let's calculate. Let's first draw the shear force diagram for this beam. So the shear force 20.8 here, and then how much will be the shear force here?
Down. 96 kilonewton down.
How much is that?
7.
59 point.
59.2. Yeah, 59. 16 ضرب 5 ناقصا 20.8.
I put very less place for the bending moment.
Next to it.
Okay, here I draw the bending moment. I think I should use this space. This is 59.2, 20.8. How much is the moment here? Positive or negative?
It's clockwise or positive.
Positive. You can also see from here.
Yeah.
96.
96.
You can also see now
In the middle.
the This is positive and this is
Negative.
so it will go up from this point to this point and then it will go
Down.
down. We don't know what. How much will be this point?
0.5
What's
multiplied
going-
16 multiplied by
How much is this distance?
5.
Oh. If you call it x, it will be.
5 minus 6.
Can you find x?
Yes. Yes, through the equations that we made.
Find it. The frame looks very simple, but when you solve, let's see. So please tell me how much is x? X you can find, it
It was
will be the
like
ratio of 20.8 over x is equal to 59.2 over 5 minus x. Okay, you won't need to find, I think.
ما راح يحلها طيب.
Or, so tell me x, please.
We know that the shear force is 0 there.
Here? Yes.
And that point.
So write the equation for shear and put it equal to 0. The long way.
1.3.
4 point. How 4.3? Total is 5. How it can be 4.3?
It's definitely less than the half. So.
So if you're taking too long for this,
Said 1.3.
how much?
1.3.
1.3?
Yes. أسمع 4.
So x is 1.3 meter. So this will be how much? 3 point.
7.
So just add this area to this point. So this point will be 96. 96 plus 1 over 2 into 1.7. How much is that? 10.4 into 1.7. Tell me the answer.
One point seven or 1.3 should be. 1.3.
1.3. Add the area of this triangle into this point.
109.
109 kilonewton meter. And now tell me how much is the moment at this point? Tell me. 109 minus 1 over 2, this negative, into 59.2 into 3.3 or 7. Sorry. So what is the answer? The moment at this point.
Minus minus
Almost 0.
but 109.5. It is 1.
That's why.
0.5. Yes.
Then it is perfectly 0.
Zero.
So you have drawn the bending moment and shear force diagram for this member. Okay. So is it in equilibrium, this member?
No.
At this point, please tell me.
No, yes. It's at 0.
The moment is 0, but what about the vertical and horizontal forces?
It's not that. Because it has 51 by 2.
For example, let's check for the horizontal. Is there any horizontal force?
No.
Vertical not.
Horizontal force, it's gone.
Yeah,
No horizontal. So the vertical force 20.8. Do we need any vertical force here?
Yes.
Yes, upwards.
Vertical up
Yeah.
or down?
Down.
Down, down.
Up.
No, it should be upwards.
Should be up.
59.2.
And calculate the moment at this point. At this point, it should be 0. 20.8 into
5.
5
6.
plus
16 into 5 into 2.
96
Zero. Zero.
minus 16 into 5 into 2.5. It should become 0.
Yes,
So
zero.
there is no moment, there is no need to balance any moment here.
Yes.
Okay, now the last member.
Teacher, one question. If I did trials to find the distance and it's equal to 0, will that be okay?
Yes. Will waste your time. In one attempt, you are getting the perfect, correct distance. If you want to make trial, it's your choice. I cannot stop you in doing that in your exam. Okay? You can also do it by writing an equation for the shear force.
Yes.
Like
0 would equal to 21.
example 20.8 minus
16 into x at that point.
is equal to, check how much is x.
Okay.
1.3. This is the other way. Write the equation for shear force here. Do you understand?
Yes.
This is the other way. But
No, the x was square or?
no, it is shear force. 16 into x, not the moment.
Yeah. 1.3.
Because where the shear force V is 0, there is a
We have
point.
16x downwards.
Okay, now next. Next, let's go to this joint.
Okay.
So I'm just going to draw this joint here. This is the joint C. Okay, so once you will transfer this force from this point, it will become.
Downwards. 51.2.
If you have any moment, you have also transferred in the opposite way here. But there is no moment, so nothing. So what about, is there any force on this joint?
No.
So in order to bring in equilibrium, 59.2. And now the last member. So the last member, it was B.
So downwards, 59.
So this member, you have a downward force 59.2. In order to bring in equilibrium.
And the reaction.
And that is a reaction. So this member is in equilibrium. This member has any shear force?
No.
Any bending moment?
No.
0, 0. Yes. So we have solved the complete frame. I give you 2 minutes to have a look on example 4.13.